my name is Erik, and I'm an undergraduate student studying chemical engineering at the University of Iowa. Go Hawks! I hope everybody is staying safe and staying healthy today, and I'd like to talk a little bit about engineering, why I think it's cool, and why I think it's a good option for students to pursue as a vocation. So why I chose engineering. In middle school and in high school, I developed an interest in scientific and mathematical subjects, and I wanted to learn how to apply those concepts in a practical way, which is what engineering is. Engineering is the application of science and mathematics by which the properties of matter and the sources of energy in nature are made useful to people. So what does engineering look like? What do engineers do? Well, perhaps you would see a biochemical or a biomedical engineer working at a pharmaceutical company like AbbVie. Or maybe you'd see a civil engineer or mechanical engineer working on a suspension bridge like this one in California. Or maybe you'd see a process engineer or an industrial engineer working at an oil refinement plant like this one. Now I'd like to go over an example of an engineering problem which I think illustrates why I think engineering is so interesting and so important. Okay, so this is something I built. It's just a old barn board screwed to a piece of plywood here, and I have a fixed point right here, and this is a continuous cord that goes through this plate here. This is a pulley bolted to those plates, and here's another pulley that's screwed to the plywood and is holding up this weight, which is a 15-pound weight. So we talk about weight. Weight is a force. So these plates, a 10-pound plate and a 5-pound plate, weigh 15 pounds and have 15 pounds of force drawing them downward. They're drawn to the center of the earth, which is the basics of gravity. And this other plate is 20 pounds, and it is pulling down straight to the center of the earth. So let's first watch what happens when this system is let loose and goes into motion. And then we'll talk a little bit about why it does that and why I think this has important consequences. So as you can see, it's snowing out by the woodpile, and there's a couple interesting things about this video that I think should be noted. The first is that obviously the 15-pound plate went down while the 20-pound plate went up. That's a little weird. And it's also important to notice that the 15-pound plate went twice the distance of the 20-pound plate, and we're just going to go ahead and break that down as to why that happened. So if we look at our system again, we can see that with this 15-pound plate, it's a force that's going straight down. It's perfectly vertical. It's going straight towards the center of the earth. But at this moment, it's not moving because I jammed a little rock into the pulley, so it's preventing it from moving. But it's not moving because it has this tension force, which is the tension of the cord, which is exactly opposite of the gravitational force. And so that force is 15 pounds. And something interesting about tensional forces is that tension is always the same throughout the cord or the string or the whatever. So if the tension here is 15 pounds, that means that the tension here and here are also 15 pounds. And since there's two of them, the upward force on this 20-pound weight is going to be about 30 pounds. It's not exactly, because these two vectors are not perfectly straight, so there would be a component in the horizontal direction, which would cancel a component in the horizontal direction here. So, but it's about 30 pounds. So why is that important? Like, so what? Which, you don't really have to be an engineer to understand how pulleys work or to use pulleys. Of course, pulleys were invented a long time ago. The Mesopotamians used pulleys, the Romans used pulleys. And so what's the big deal about pulleys? And that touches on an interesting concept in engineering, an interesting pattern, which is that engineered devices sometimes come before the understanding of the device. So like, people were using pulleys without understanding gravity. They were like, the Romans were using pulleys as a device to lift weights, but they didn't understand gravity and they didn't understand tension. So it's an example of engineering that came before understanding. But once you have an understanding of something simple like this, for instance, pulleys, you understand tension and you understand gravity. And when you understand tension and gravity, you can start to understand other things. Like, you might be able to look at this truss, and it's not just tension going on here, there's a lot of other things. There's more forces, there's moments, there's tension and compression. But if you start to understand the basics, you can look at something like this and analyze what's happening, analyze what's going on, with a little bit of trigonometry and calculus. And then maybe you can make something a little bit more complicated, something like this, where you're just expanding on the knowledge you already have of trusses, and you're analyzing more forces in a more complicated system. And then maybe you can take something exceptionally more complicated, like this building from Beijing, China. And that's what engineering is. You're taking little ideas and building off them until you reach a point where you can understand principles in the real world. But that doesn't mean that you can't use engineering principles, basic engineering principles, early on. And I will say, I've used principles from algebra, I've used trigonometry, I've used physics and chemistry in my life outside of the classroom. And of course, as an engineer, I use all of these principles consistently. So in conclusion, I would encourage students to check out engineering just because I think it's very interesting. And if you have leanings towards science or you enjoy math, it's definitely something that you should check out. It's definitely something that you can look into. Look up a local university, look at their engineering program, maybe look up different types of engineering to see which one might fit you. And I would recommend taking your classes seriously now, whether you're in middle school or high school or whatever, because algebra, it's going to be useful for the rest of your life. It really is. And like I said, I've used trigonometry, I've used physics and chemistry in my life. But remember to also have fun in classes, because learning is fun, and I think that you should enjoy what you do, and so you should choose to do something that you enjoy. Thank you for listening to the presentation, and I hope everybody's staying safe and staying healthy. Thank you.